Hey guys, welcome back to the channel. Today we're still on Leetcode 153, finding the minimum in a rotated sorted array. We've solved this problem a few different ways in the past, but today we're going to solve it using two methods of dynamic programming. In the past we used pointers, right? Okay, which is one element of dynamic programming, or DP. And now we're going to use both pointers and recursion, okay, which is two dynamic programming methods. So let's go forward with this. Okay, so we're gonna take this was our previous solution, we're gonna take them out. Okay, and this solution is really similar. Like always, we start with our pointers L and R. Okay, feel free to pause it to read through the problem again, but if you follow the past two videos, you see it's the same problem. We're given this array, okay, and we want to find the minimum in the array. Okay, we're gonna find this point. Okay, so yeah, we're given L and R. Okay, this is pretty standard for binary search. Okay, every time you see log n, we know we want to do binary search. Okay, always first is always to define your L and your R, your left and your right pointers. Okay, and the formula for left and right pointers is always standard, always the same, 0 and length of nums minus 1. Okay, pretty straightforward. Okay, so first we want to say if for some reason L equal R. Okay, meaning if the first element in the array is the same as the last element. It's the same method of saying if there's only one element in the array. Say if length of nums equal 1, then we just want to return nums of L or R. It doesn't matter, L and R are equal. Okay, so that's all we want to do. Okay, else we want to calculate the midpoints. Okay, mid, again, formula is standard. Okay, right plus left or divide by 2. Okay, again, remember we're using both pointers and recursion in this problem, so which is the double D approach to this. So first check if our midpoint is less than R. Typically it should be less than R. Okay, if it's less than R and okay, nums of mid, okay, is greater, okay, than nums of mid plus 1. Okay, what do I want to do in this case? I want to return nums of mid plus 1, and I'll show you what I mean by this statement. So pretty much using our same example we've always been using. Okay, so given our nums, okay, our nums is still the same example, 3 4 5 2 1. Okay, this is saying again we just defined our left, our right, and our midpointer. So left is right here, our left pointer. Okay, this is index 0, index 1, index 2, index 3, index 4. Okay, R is right here, mid is somewhere right here. Okay, so this is saying simply if mid, okay, is less than R, in this case mid is 2, R is 4. Okay, mid is obviously less than R, and if num of mid is greater than num of mid, so we're saying if num of mid in this case, which is 5, is greater than num of mid plus 1. Okay, num of mid plus 1 is 2. Okay, if 5 greater than 2, in this case obviously 5 is greater than 2. I'm sorry, I switched these elements, so this is supposed to be 2 1, not 1 2, not 2 1. Okay, so it's simply saying if nums of mid, which is 5, is greater than nums of mid plus 1, which is 1, which is obviously, it's saying that is our inflection point. That is the point where the array was rotated. Okay, that's the axis of rotation. Okay, so just return num of mid plus 1, which is that guy. Okay, so this part is pretty straightforward. Okay, now the next line is kind of straightforward too, but not as straightforward, but again it's not a bad problem. The next line says if mid, okay, just the opposite of the previous line, is greater, okay, than L. Okay, if mid is greater than L and nums of mid, opposite of the previous line, it's less than nums of mid minus 1. Okay, if this is the case, what do we want to do? We want to return nums of mid. So I'm just going to copy and paste this. Again, I'm going to explain it with our good old problem. Okay, I'm going to wipe everything off from the past one. So all this is saying is if mid, okay, mid is 2, is greater than L, L is 0. Obviously that first part is true, mid greater than L is true. And if nums of mid is 5, if she's less than nums of mid minus 1, if it's less than this, okay, in this case it's not, But if it's less than this, okay, if this is less than this, that means the inflection point is right here. In this example, the inflection point is not right here. I'll give you an example that might fit this. An example that might fit this is if we move it back one more, say it was 4, 5, 1, 2, 3. Okay, this will fit this. So in this case, this will be L, this will be R, and this would be mid. In this case, okay, 0, 1, 2, 3, 4. Okay, in this case, nums of mid, okay, which is 1, nums of mid is 1, is less than nums of mid minus 1, less than 5. So here's our inflection point, and we just want to return nums of mid if this were the array. But in this case, this is not the array, so this if block is not going to execute. Okay, we've established for this array right here, this if block is not going to execute. Then next, after this, it's pretty straightforward from this point, right? So if nums of R is greater than nums of mid, okay, if nums of R, if the higher number is on the right side, if the higher number is on the right side, okay, for some reason, for whatever reason, okay, the higher number is on the right side, we want to return. Call the function recursively on himself. In this case, we want to do self dot. Okay, call the function recursively. And what do we want to pass into him, right? We want to pass nums, the same array. Okay, the bigger number is on the right side. Okay, so we know he's incrementing, so the minimum cannot be on the right side. So we want to pass L. L stays the same till mid minus 1. So essentially, all we did is we moved the right one step inwards. That's what this is. Okay, we kept the left where he was, we didn't change him, but the right we moved him one step inwards. Okay, now this is pretty straightforward. But so if it doesn't go in this if block, we can use the else statement, but I'm choosing not to use the else statement. It means the reverse of the case. It means nums of R is less than nums of mid. In that case, we want to return pretty much the opposite of this. So L is gonna be +1. Okay, we got L is gonna be mid +1 actually. Okay, and R is gonna stay the same. Okay, so this pretty much looks like it. We didn't need no while loop because we're using recursion, and at the same time we're using pointers. So I think this is correct. Let's go ahead and run it and see. Okay, accepted. Let's go ahead and submit it. It said we're going out of range. Okay, let me try to figure out what's going on. So for some reason this method keeps failing and I can't seem to figure out what's going on. So do not use the double D method. It's kind of too dynamic and there's bound to be issue. But for most test cases it works though. But Leetcode is not giving me much details on what test case is failing for. Okay, it just says index out of range. Okay, so I think it's failing for this example somehow. Okay, failing for this guy somehow. So let's try it and see. Change the test case. Okay, let's run the code and see why he's failing for that specific guy. Okay, for some reason we're going out of index. So yeah, guys, do not use this method. Use the other 4 methods I showed you in the previous video. That's it for the video, guys. I hope this was helpful to show you guys what method not to use or what not to do. I'll see you guys in the next one.